This is exercise 25, dealing with the functional anatomy of the digestive system. The functions of the digestive system is ingestion, which is taking in the food, and the digestion, which would be breaking it down into the various smaller nutrient molecules, and then absorption, which is taking those nutrients now into the bloodstream so they can go systemically where they're needed for all the cells throughout the body. And then defecation is elimination of any of the waste products. In terms of the digestive organs and then the accessory organs that assist with that, you have first the oral cavity and the tongue, where everything begins with the chewing. You have the salivary glands that assist by providing moisture, and actually you have in the mouth the beginning of digestion occurring. Carbohydrate digestion will begin here. Of the salivary glands, there's 3 different types: the parotid, sublingual, and submandibular ones. So once you swallow, the tongue's going to help, and the teeth chew up the food, and the tongue's going to push the food to the back of the oral cavity, and finally there's a point of no return where it's going down, and so it ends up in the pharynx, the back of the mouth. Down the pharynx then, the pharynx is shared with the respiratory system in terms of breathing. The epiglottis is going to cover the trachea so the food does not go down the trachea and into the lungs. Instead, it goes down the esophagus. From the esophagus, it's going to go down, and then when it hits the stomach, there is a sphincter there, a muscle, and when the bolus, which is what we call the food item at that point, when it hits that sphincter, it will open up, allowing it into the stomach. Now, you can kind of see in this picture, the pancreas is located kind of behind and under the stomach. It is the yellow structure. You can barely see the spleen, which is tucked away over on the side. It's kind of a purplish color. A lot of people will confuse those 2 structures. The pancreas is an accessory structure for the digestive system. You can see the liver sits on top and to the side of the stomach. Underneath the liver is the gallbladder. So the food has come down the esophagus into the stomach, where now the stomach is very acidic. You're going to have protein digestion occurring there. The carbohydrate production that started because of the salivary juices stops because of the acidity in the stomach. In the stomach, then, the food is going to move into the small intestines. In the small intestines, the acidity from the stomach is the chyme, which is what the food substance is called now, will be neutralized. In the small intestines is where we have most of the digestion and absorption occurring. So you're going to have carbohydrate, protein, and lipid digestion occurring. The small intestines is divided into 3 components. You have the duodenum, the jejunum, and the ileum. And then the remaining substance is going to move to the large intestines. It will first move into the cecum, then up the ascending colon, across the transverse colon, down the descending colon, through the sigmoid colon to the rectum, and then finally out the anus. The appendix, as you can see, is just after the small intestine, large intestine junction. It's often referred to as a vestigial organ in that it doesn't have a main purpose anymore. Unfortunately, it can get blocked and become infected, and if it ruptures, that is a huge problem, because then everything in the intestines can go into the abdominal and pelvic cavity. So that needs to be treated immediately. So if we look a little bit closer here, and starting with the mouth, when you chew, obviously you're going to be chewing the teeth, helping to break it into smaller components. The tongue is a muscle. It's helping to move the food around in the oral cavity, mixing it with the saliva, which is helping to moisten it. You can see the placement of the tonsils, which are helping they're involved with the immune system in terms of helping to recognize any potential pathogens, any potential foreign objects that you know may be carried in on that food. And then once the food is pushed to the back of the oral cavity, it's going to go down to the oropharynx, down the laryngeal-pharynx, and as you can see, the esophagus is behind the trachea. So hopefully, if you swallow correctly, then the food goes down the esophagus, not in the trachea. If you look at the mouth, the anatomy of the mouth itself, you have shown here the upper lip, the gingiva, which are the gums. You have the hard palate in front, the soft palate behind that, and then the uvula is that little tissue cartilage that hangs down. You can see when you open your mouth wide. If you touch either that or to the side of it, you will initiate what is known as the gag reflex. You can see the palatine tonsils, and then the very back is the oropharynx. Most of the alimentary canal wall, or the digestive canal wall, is similar in that it contains 4 layers, as you can see listed on the right-hand side in the bold black: the mucosa, the submucosa, the muscularis externa, and then the serosa. One thing I want to point out is that if you look at the muscles, you will notice that the fibers are going in different directions. So one's going to be circular, the other is longitudinal, and that assists with the movement. We have both peristaltic and segmental movement that helps to push the food along through the digestive canal. This is showing the anatomy of the stomach, so you can see where the top left, where the esophagus comes in. And for the stomach, there's 3 different layers of muscles, and all of them the fibers are going in different directions. Once again, as they all contract, it really helps with the mixing and the churning to aid in digestion. In the stomach, you have protein digestion occurring. You'll also notice the rugae, which allows for this folding for the stomach to expand, increasing the volume and the capacity that it can hold. The upper portion of the stomach is known as the fundus, the middle portion is the body, and then down at the bottom portion is the pyloric area, and you have the pyloric sphincter. This is a muscle, it's a valve that is going to allow the food, typically as it's coming, the little segments of food coming down the esophagus, we refer to as a bolus. As it leaves the stomach, it's very acidic. We refer to it as chyme, C-H-Y-M-E, chyme. The pyloric sphincter is going to open and close and just allow a small amount, only about 3 milliliters out at a time, so that you don't have the sudden influx into the small intestines. And the beginning portion is called the duodenum. You want to regulate so you don't have this sudden influx with that low pH. So it regulates the amount that goes through into the small intestines. Now in the stomach, because you are producing acid that's assisting with that protein digestion, there are certain cells that are releasing the acid, and this is occurring via the gastric pits. As you can see, these cells are embedded down below the surface for protection. As I said, the small intestines is divided into the 3 different subdivisions. And in order, it's the duodenum, the jejunum, and the ileum. As you can see in this diagram, as the food moves out of the stomach into the duodenum, you need to neutralize that acid of the chyme. The pancreas, which is tucked under and behind the stomach, as you can see here in this diagram, it is yellow. It is producing the pancreatic juices, which will help to neutralize the acidity of that chyme as it enters the small intestines. The pancreas is also going to be including insulin to help break down glucose. The pancreatic juices are going to move through the pancreatic duct and drain into the small intestines. It's also at the same location of where the bile duct is going to be bringing the bile. The liver makes bile, and the excess bile is going to then be stored in the gallbladder, which you can see here is the green structure. It's typically located underneath the liver, kind of under and behind it. The gallbladder does not make the bile, it just stores the bile. And it will be released by the cystic duct and then go down the cystic duct and the hepatic ducts, which are coming from the liver. They join together, they merge together, and they will form the bile duct. And then that will drain also into the small intestines with by the pancreatic duct. Bile is going to help with lipid or fat digestion. So if somebody has an inflamed gallbladder where it needs to be removed, they are still producing bile because it's the liver that produces the bile, but they can't store extra, which means because they can't store extra, they don't have a whole lot of bile at any one point in time, and bile is used for lipid breakdown, so they're going to have to watch their intake of fats and lipids from that point on. In the small intestines is where you're going to have most of the absorption and digestion, because now you have lipid digestion, you have carbohydrate digestion, start up again, protein digestion continues, and then you're going to have reabsorption occurring and absorbing all of those nutrients from the small intestines into the blood supply. So there's a very good strong blood supply to the entire digestive system, but certainly to the small intestine, so you can have absorption of all those nutrients. From the small intestines, now anything that was not absorbed, anything that was not broken down, will move into the large intestines. Now the large intestines, some people think, well, how did it get its name? Because it's shorter than the small intestines. We're looking at the diameter. So the diameter is bigger. That's why it's called the large intestines. The ileocecal valve is this valve from the small intestines into the large intestines, into the cecum area. It's the first area of the large intestines. So from the cecum, just right off to the side is the appendix, which I already spoke about. Then you have the colon, which is collectively referred to as, you've got your ascending colon, the transverse colon, the descending colon, the sigmoid colon, and then finally into the rectum, and then the anal canal. So as you can see here, the large intestines, how it bends and circles around. The main purpose of the large intestines is going to be, there's a little bit of digestion that occurs. You're concentrating the waste into the fecal matter, and you're reabsorbing water from those waste products. The accessory digestive organs are going to be the teeth, the salivary glands, the pancreas, the liver, and the gallbladder. The teeth, the deciduous teeth, are the commonly referred to as milk teeth or the baby teeth. You have more permanent teeth. Now, we do give the teeth different names. There are the incisors, the canines, the premolars or bicuspids, and then the molars. They each have their own purpose. Like the incisors are used for chewing, tearing, which you're very familiar with. If you're eating on something, you use those front teeth to help pull or tear the food apart. But the molars are used for chewing. This is showing a cross-section of a tooth. The enamel, the outer portion, the white portion that you see, that's the crown that's covered with the enamel. Underneath that is the dentin. In the very interior portion is the pulp cavity that contains the nerves and the blood vessels, and that will extend all the way down through the neck and the root portion of the tooth. The neck is right, the area normally in a healthy individual you really should not see because it's right below the gum line. And then the root extends down into the bone. It's held in place by the periodontal ligament. And like I said, there is good blood supply and nerve supply up through the root, up and through that pulp cavity. In terms of digestion, digestion of your carbohydrates, this begins in the mouth, like I said earlier, with the salivary amylase, and then it will continue in the small intestines. And then you're going to be absorbing all of that in the small intestines. Proteins. Protein digestion occurs in the stomach. It is able to occur in that low pH. And then it's also going to continue in the small intestines. And then the absorption of it, like I say, absorption of all the substances will occur in the small intestines. And then your digestion of your fats. This occurs in the small intestines because of the addition of the bile and the pancreatic juices that are added in the small intestines.